In this video, I am going to show you how you use gen keyword in Gaussian calculations. So first, let's prepare an input file for calculation. Open Gauss view on your computer, then click on the periodic table tool and choose neon. Choose the neon atom fragment, then left click on the view window and we have drawn neon atom. Next, go to Calculate, Gaussian calculation setup. We are going to choose job type energy. For the methodology, we will choose Hartree Fock, and for the basis set, we will choose gen. Let's go to title. We will call this calculation neon atom, and I'm going to use CCP VDZ basis set. Go to link 0. For the memory, specify 1 gigabyte, and for the shared processors, let's choose 1. Make sure that for the checkpoint file, especially if you want to submit this to a remote system for calculations, that you have unchecked the full path. Next thing we need to do is to add input for the basis set. So click on Add Input tab, and in here we are going to specify basis set for neon. So we type NE for neon, 0, and then on the next line you type the basis set that you have chosen to use with neon atom. So in this case I want to use CCP VDZ basis set. Then finish this section by typing 4 stars. If you have more atoms in your input file, you can specify basis set for each of them here. Let's say if I had argon atom here, I can type argon 0, and then I can choose basis set that I want to use for argon. Let's say I want to use 631 G star basis set. I can type it here and then finish this section by typing 4 stars. Okay. So I don't have argon here. I'm going to delete this. It is important that you end this additional input section by adding a couple of blank lines. Let's go to preview, where we can see preview of our input file. So in here I'm going to use 1 processor, 1 gigabyte of memory for calculation. I'm going to do single point energy calculation at the Hartree Fock level with a generated basis set, and you can see the basis set that I have defined at the end of input file here. You can also make these more complex. So for example, Gaussian has CCP-VDZ defined. But if I want to use a basis set that was not defined in Gaussian, I can go to one of the basis set exchange website, obtain the input format for the basis set, and I can enter it in this place here. So now I will submit the calculation. I'm going to do the calculation on my computer here, but at this point you can save this file and transfer the input file for a calculation on a remote system. So I'm going to click Submit, click Save, and I will say save this as neon atom CCP VDZ. Click on Save. Yes, I want to submit this file to Gaussian for calculation, so I will click on Yes. This is a very fast calculation because the basis set was quite small. So now I want to open the log file. Choose the log file, click on Open. And what I would like to show you here is how you figure out how many basis functions were used for the calculations and how long the calculation took. So go to Results and click on View Edit File. So this will open the actual log file in a text format. I will go to File, actually I will go to Edit, Find, and I will search for n basis. Okay. So this brings me to the section of log file that gives me information about basis sets. You can see this starts with general basis set read from cards. This means that this basis set was defined via gen keyword, and also this is telling you that spherical Gaussians are being used in the calculation by showing you 5D 7F here. This piece is important one. You can see that 14 basis functions were used for calculation that are composed of 33 primitive Gaussians, and these correspond to 15 Cartesian basis functions. Now, the actual number of basis functions used in calculation was 14 because these were done with spherical basis set. So n basis gives you the actual number of basis functions used in calculation. I can go to the very end of the file to figure out how long the calculation took. And you can look here at the line that says job CPU time. So this is telling me that the job CPU time took 0.6 seconds.